Hey everybody, this is Miss Eisencraft with Unit 2, Lesson 9, Practice Problem Help. Okay, question number 1 does not come from your book. We made this problem up. All right, let's just dive right in. Kayla is selling bracelets for 15 each and necklaces for 20 each. She made $670 last month in online jewelry sales. Part A, everybody's favorite. Let's write an equation. So if we're going to write an equation, let's write in words what we want to know. We know she made her total sales, right? We want to say, what were those made up of? Well, her total sales were made up of all the money she made, money from bracelets, plus all the money she made from necklaces. So if you struggle with writing equations, first, like maybe just write a verbal model and then replace what you know and put variables in for things you don't know. So we know her total sales were 670, right? We know that. We know money from necklace. We know each necklace is 20. But we don't know how many necklaces. So it does say to use Y for number of necklaces. It's not asking us to solve this, okay? Money from bracelets can be represented by the expression 15 for each bracelet, and we're using X bracelets. So this is the number of bracelets, and this will be the number of necklaces. We know the price of each, but this equation now will help us solve the other part. So let's go ahead and type it in. 15x plus 20y equals 670. I didn't use any spaces, hoping Canvas will register my answer is correct. Fingers crossed. Okay, next problem says solve the equation for x. So this part, when you solve for x, again, you're still not getting an answer necessarily. I did not mean to do that. Boop. Okay, solving for x, what we're going to do is we're going to take this equation. Solving for x means get x alone. You would use this if you know how many necklaces she sold and you're trying to figure out how many bracelets it was to reach the 670. So if you're ever trying to figure out x, you would want to use an equation that has x isolated or x all by itself. So what I'm going to do is I'm going to get x alone. X was multiplied by 15 and then 20y was added to it. So I want to subtract 20y. So you want to subtract all the money she made from the necklaces. So if you take 670 and you take away $20 per necklace, it's okay that we don't know what that is, okay? Then this expression will be how much she made on bracelets. But if you want to know how many bracelets that was, you would need to take that total and divide by 15. Divide the whole thing by 15. So the number of bracelets sold is 670 minus 20 per every necklace, $20 times necklaces, divided by 15. So we didn't get an answer. What we did is we got an equation we could use, x equals. We got an equation we could use to solve or figure out number of bracelets had we been given number of necklaces. Because Canvas doesn't have a fraction bar, I'm using grouping symbols to show I'm dividing all of that by 15. Okay, clear. Yay, I didn't close it. Number 2, a lot faster, I think. The area of a rectangle is represented by the formula area equals length times width. Okay, easy enough. Okay, where L is the length and W is the width. The length of the rectangle is 5. Well, that would be, yeah, okay, I'm just replacing that. Write an equation that makes it easy to find the width of the rectangle if we know the area and the length, which we do, right? So if I want to find the width, I want to get width alone. If I want to solve for W, I'm just going to divide by 5. So the width is just the area divided by 5, or the width is the area divided by whatever length it is. It told us the length was 5. I'm going to plug this in. Let me see in the book if that's the actual, did they want us to use the 5 or the L? Oh, it has both. Awesome. Okay, I'm going to use A divided by 5. I didn't catch that at first, that it gave you. Use capital A divided by 5. Okay. All right. And again, if Canvas ever counts these as incorrect, but you're following the teacher tutorial, remember Canvas is a robot and sometimes things are entered incorrectly or it's not reading your answer incorrectly. So please don't worry about that too much. You can let your teacher know, but don't worry about it too much. All right. Question 3. Here we go. The volume of a cylinder. Remember these cylinders from middle school? The volume of a cylinder is calculated by taking pi r squared times h, which is the area of a circle times the height. Okay. It says which equation would allow us to easily find the height of the cylinder because it is solved for h. Okay, if something is solved for h, it means h is alone. Okay, well, h is being multiplied by pi r squared, or pi times r times r. So to unmultiply, you would divide. And you don't need to divide each of these separately. You can treat this as one product. So if you take the total volume and divide it by pi r squared, or the area of the circle, you will be left with the height. Let's see if we can find one of these guys. Somewhere here. Nope. Boom, boom, boom. Okay. Question 4. The table shows the volume of water in cubic meters, V. Okay, that's on, right, I don't like how, it doesn't really show. This is another screen. Okay, it's like a table like that. And this is time after the pumping begins in minutes. Okay, that was loud, sorry. Which equation could represent the volume of water in cubic meters after t minutes? In order for an equation to work, it has to work in all the pairs of numbers given for t and v. So what I'm going to do is I'm going to start with this first equation here, right? And I'm going to type it over here in Desmos. Are we ready? Let's go ahead. I have to hit clear. Oh, my mouse. That's what I have to hit. There, I did it. Okay, so I'm going to take 30 minus 2.5 and then do parentheses. Okay, if I plug in t, which is the number on the left, I should get the number on the right. So I'm looking this way, right, for all these pairs of numbers. Now, just because it works for one pair doesn't mean it's correct, the correct equation. It has to work all the way down the table. So if I plug in a 0, yay, I get 30. What about if I plug in a 5? It falls apart on the second one. So nope, first one is not correct. Okay, this next one, it's a new equation. So let's type this in. Right, 30 minus 0.5, and I'm going to plug t right in there. So let's start by plugging in a 0. That makes 30. So I'm starting here again. Now let's plug in a 5. Okay, it works on the second one. Next, I'm going to plug in a 10 for t. Oh, tomfoolery. It doesn't work. Okay, clear, clear, clear. This one also doesn't work. Okay, let's try another one. 30 minus 0.5 and then t, and then we're going to square it. The squared button is right here. Okay, let's try a 0. 0 works. Let's try a 5. Oh, stop it. Let's try a 5. 5 does not work. They would make it the last problem. Okay, last one. It changes this to a 0.1, and we'll try all the numbers. It's possible I made a mistake. 0, that works. 5, that makes 27.5. 10 makes 20, and 15 makes 7.5. There's your winner. Okay, those inputs and outputs worked for those pairs of numbers worked in the equation each time. So this is your equation that represents the table. Okay. Last problem. Oh, not even close. There's 2 more. Okay. A catering company is setting up for a wedding. They expect 150 people to attend. They can provide small tables that seat 6 people and large tables that seat 10. So it says find a combination of small and large that seats exactly 150. So we could, mess around with the numbers until we get 150, but I'm going to jump straight to the equation because we did this last time, and I'm going to use Desmos. I'm going to show you. Okay. Back here, go to Desmos, and I hit graphing calculator. I'm going to go ahead and type in the equation. So this is part 2. Okay. If X represents the small tables, okay, and Y represents the large tables, I am going to make an equation. 6 people for every small table plus 10 people for every large table. And we need it to equal exactly 150. This should look familiar, like from last week, these types of problems. Okay. Let me zoom out just a little bit. Zoom in just a little bit. Okay. So the X, this is the small tables down here. Let me hit my little marker. Okay, this is small tables. And this is large. Okay, and we use the equation for number 2. We use 6. This is number 2 in the problem. 6x plus 10y equals 150. I just jumped right into a line because it's way easier. Everything on the line is a solution, right? So you could do 25 small tables and no large. You could do 15 large tables and no small. And everything else on the line that follows on it, because you can't have a fraction of a table. Everything that falls on a nice spot on the grid would be another combination that would work. And again, you could just keep playing around with the numbers until you figure that out. But the line is so nice. You could do 20 small and 3 big, 15 small and 6 big, 10 and 9, 5 and 12. All of those combinations would make it equal 150. Okay. So I answered number 1 and number 2. Now it says, explain what the point 25 means. So it's asking you about this right here. Okay, what does that mean? Well, the point 25 is right here. I'll make it also pink. Yeah. Maybe it is pink. I don't know. It means 20 small tables and 5 large. Okay, because 20 is X, which is small, 5 is large. So what it means is that 25 would mean that would be 20 small and 5 large, and you might be saying it's not on the line. And that's correct. It does not equal 150 people. It actually would be more. Okay, it's not a solution. And if you wanted, it's not on the line, but you can also say, if I tried $60 times 20 plus 10 times 5, does that equal 150? It doesn't appear to because it's not on the line. Let's look. 120 plus 50 does not equal 150. It equals 170. So if you chose that combination, you would have extra seats, which then you could decide if that was a bad choice or a good choice. But it's not a solution. It does not equal 150. Okay. Now, last one, I promise. Question 6, which equation, it's only one, has the same solution? So I'm not actually going to solve, I'm just going to inspect it here. Okay, so I'm going to inspect it and see what happens. I don't believe we need our calculator on this. Okay, so Let's look at the original equation and then let's look at how they changed it. We had a 10x minus x plus 5 equals 41. Here, they took away the x, or they got rid of the x, so maybe added it, but then they didn't do anything to the other side. You just can't willy-nilly take out that x. What? That is incorrect. So this won't be the same because they removed that x. The next problem, so this is a no. Oh, what? That's because I have the select tool on, you nerd. Okay, next one. It looks like they moved the x and the 5, they switch places. Okay, that would be okay, except for the 5 is positive and the x is negative. They can't change signs. So that's changing the value of the equation. No. This one, they put the 10x and the minus at 1x together and made a 9x. That's good. But then they got rid of the 5. That's okay if you take it away from both sides. They took it away from the left, but they added it to the right to get 46. So hopefully last one works. 9x, yes, plus 5 equals 41. This is your winner. Okay. All right, guys. Thanks for watching. Good luck.